We are taking a question and answer on 8085 microprocessor. Explain briefly the flag register in the 8085 microprocessor. So the flag register, these are basically flags. So these flags represent after certain operation, what has happened, what is the state, what are the changes. So this flag register tells you about the status or situation. So let us take one by one flag. First, let me tell you the flag register is in 8085 is an 8-bit register, and it contains, this all flag contains 5-bit position, that is 3 we are not taking, but in all 8 it can be set 1 or it can be reset, that is 0. So these 5 flags are 1 bit when they are set, otherwise they are reset. Okay, so this 1 means that this particular flag is set. 0 means this is reset. Okay, so let me tell you about one by one, D0 to D7. D0, so this flag D0 is a carry flag, and this gets set when there is a carry generated by an operation. If we do some add or some subtraction and we need to carry certain thing, so this will be set, otherwise reset. D0. So we are not talking about D1 and D3 and D5. We are talking about D0, D2, D4, D6 and D7. So these 3, 8 minus 3, this, so 5 are being used. Okay. D2, parity flag. So when we have even number of ones, this parity flag is set. That is, if we have 1 1 or 3 1 or 5 1, it will be reset. Even number of ones only, then this parity flag will be set, like 2 ones, 4 ones or 6 ones, like that, right? Now coming to the auxiliary carry flag. Now this auxiliary carry flag is set when there is a carry out of lower nibble. Nibble means, since see we have 8 bits, so the lower part or the 4, 8 consists of 4 and 4. So the lower nibble or lower 4 bits of the operation, when there is a carry out, then we say it is auxiliary carry flag. This is used for BCD operation, not very much free to the programmer. This is auxiliary carry flag. Now coming to 0 flag. This is D6. So this, when you have done certain operation and the result comes as 0 0 0 0 0 0 0 0, that is, when the result of the operation is 0, then it will be set. There's sign flag. Sign flag, for example, this is a bit sequence. This is 1. That means this sign flag will get set when the result of an operation is negative, right? Okay. List out the function of accumulator. So before I can tell you about accumulator, let's go ahead and see here the architecture of 8085 microprocessor, where the accumulator actually lies. So we will talk about the registers like BCD, HL, stack pointer and the program counter, etc. But here we have accumulator. Why it becomes so important? Because accumulator, this is a 8-bit register first of all in 8085. So register is nothing but the combination of flip-flop. So 8 flip-flop means 1 register. So this is a part of ALU, arithmetic logic unit. This is the important part. So this particular register is used to store 8-bit data and also to perform the arithmetic and logical operations. So the result of the operation is stored where? In accumulator. So we identify it using register A. So accumulator holds one of the data or the data which is processed by LU, and also it stores the result of the operation. So it's a operation holding area. So it also works as a VIA, that is the route register for input output accesses. What does it mean? It reads data from the input device and it transfers the data to the output device. This is your accumulator. What is program counter? So we also call it as PC in 8085. So let me tell you about this whole situation here. We have certain register B, C, D, E, H, L. These are general purpose register. We have flag register, we have accumulator A. Now in order to handle all these, or in order to handle the data, we have certain say supporting program counter or stack pointer like this. These are also the register. So they are special purpose register. So program counter is a 16-bit special purpose register. So when we have a program, this special purpose register of 16-bit program counter, while we are working on certain say this instruction, the address of the next instruction is held by program counter, or you can say this program counter hold the memory address of the next instruction to be executed. What is a stack point register? Describe briefly. See, stack, we'll talk about stack in a while, but the stack is a memory, that is, it is an area in random access memory which is given for certain temporary storage of data. So when we implement a stack, it is in the RAM, random access memory. This is how it is logically seen. So stack is data one over another. So the last input data will be the first to be output data, last in, first out. This is called stack. So this SP, what you see here, this is a 16-bit register. This is used to point, or it indicates the stack. So in read-write memory, that is the RAM, the location at which the temporary data and return addresses are stored, so this is known as stack, because we need certain place to have some return addresses to be stored, etc. You can just say that stack, it acts like an auto decrement facility for the system, for the microprocessor. So the initialization of stack top is done with a proper instruction, that is LXI SP. What you see here is there is starting address initialization. So this initialization, this is with certain instruction. So now when this instruction is executed, the stack is being made. So you put the items on the stack one by one. So this is called the push operation. So you can have a push operation, or there can be a pop operation, because what you have put in on a stack, you need to pull it out also. That is called popping, pop out. Okay. So always stack pointer will point to this address, the top of the stack. What is stack and subroutine? Stack is a temporary memory location at the random access memory, RAM, and for say some temporary storage of data or the return addresses, this stack is used, like stack of plates. So the last plates to be put is the first to be taken out. This is a concept. So when we implement, we ask with certain say statement instruction LXI SP like that. So the stack is created, one by one we put the data, and then we take out the data, pull out the data. So pushing, that is populating the stack, and popping is depopulating the stack. The stack, it is the set of memory locations in memory. But subroutine is that you have a main program. Okay. Now there are certain tasks which are to be repeated again and again. So rather than writing that code again and again, we can make a function, or we can, in the microprocessor language, we call it as subroutine. So this control goes to the subroutine and comes back. So subroutine is the group of instruction. It is written separately from the main program to perform a function that occurs repeatedly in the main program. For example, you are calling add function. Why not to just make a function add? So you have certain instruction, means this is the flow of the program. So this is the flow of program, one instruction, second instruction, like that. But when we come to the subroutine instruction, that is when we call subroutine instruction, that subroutine will be called, and there will be some input that will be given to subroutine. Subroutine will give you some output, and then the flow of the program continues. For example, you give 2 and 3 and you get 5. That 5 is returned to the program, and the flow continues. So I'll show you a very simple program here, and this program is showing this subroutine of assembly language. So everywhere you see there is a call to delay. There is a subroutine named as delay, and we are calling it. So we are calling it number of times in this program. So this control goes and then it comes back again to the main program. So this all call delay, call delay, call delay. What are these? These are subroutine. Okay. Name 5 different addressing modes. So addressing mode in 8085 and various other processor. Every instruction, every, you can say, program line of a, you can call it as an instruction, has to operate on a data. That is, if you do move, you move MVI, LXI, or any DAD, it is working on certain data. There has to be some moving of what? Data. So every instruction is operating on certain data. So the method or the technique or the way of specifying the data to be operated by the instruction is called addressing. That is, the instruction can say, tell, oh, this is the data. In instruction itself, the data is there. But if the instruction can say, oh, this is the address of the data, or it can say the address of the data. That is, you can say, okay, you are saying something to your friend. You have to come to that corner. This is, you can say, there is my house. Or you can say, come to the corner, ask the fellow there, and he'll tell you my address. So there can be different kind of way the data is being specified. Address of the data. Immediate addressing, direct addressing, register indirect addressing, implied addressing. These are different type of addressing. So these 5 you have to remember, because this is only the way of indicating or specifying the address of the data, because it's all about data in any kind of instruction. Define indirect addressing mode and give an example, and also explain immediate addressing mode. We'll talk about both of these. Everything is happening of data. Every instruction is working on certain data. So when it is talking about data, instruction can tell you directly the data. It can tell you the memory address of the data. It can tell you the memory address which contains the memory address of data. So you can tell your friend, okay, come to that shop. Behind that I have my house. Or you can say, come to that shop, ask the fellow, he'll tell you where to go. So you are actually telling the different kind of data positions. So that is called addressing. So we have 5 different kinds of addressing mode. So in this indirect addressing mode, the instruction specifies the name of the register in which the address of the data is available. The instruction will tell you, indicate you the name of the register. That register in which the address of the data is available. Did you get it? Okay, I'll show you with a diagram here. Okay. So that diagram will tell you what is, because it is not direct, it is indirect. So you are not telling the direct address of the data. You are telling that this will have the address of that data. Okay, let me tell you again, the instruction here we have an opcode and here we have a register. This register will have an address and that address will have the address of the data. Okay, in immediate addressing mode, data will immediately follow the opcode, operation code in program memory. So this is your instruction, this is your opcode. There are two parts actually of any instruction. So the operand comes from next byte in a program memory. So let me tell you again, this is immediate addressing mode. It tells you, the name itself tells you, the data will immediately follow the operation code in the program memory. In all these expression, in all these instruction, you see that these are based on immediate addressing mode. This question we'll take in the next discussion. Then thank you so much. Take care of yourself.